Okay guys, 4090, you better grab your popcorn. This video I'm going to show you the behaviour in the coils of this machine. I'm going to show you how to drop the voltage in the run coils while keeping the same watt input to the motor. I'm going to show you how to lift the voltage in the run coils keeping the same watt input to the motor. I'm going to show you the rotor speeding up when we add a load to it through the generator coils, and I'm even going to show you a dead short across the generator coils and the effects that has. Like I said in my previous video, I'm not really worried about the charge. I just wanted the pulse motor side of things. The charge is just an extra bonus. We will have a look at the charge and keep an eye on that in case there is some there that think I'm losing the same amount of charge as what I'm putting into our load through the generator. I'm then going to show you on the same amount of watt input to the motor while the generator coils are dead shorted, that the charge actually goes up higher than what you see it now. I'm using my power supply, of course, so the voltage and the amperage is steady. With batteries over time, of course, the voltage is going to drop, which will affect everything slightly, but nothing is going to change within this system. When I do the tests, every test I'm going to do, I'm going to keep the watt input to the motor exactly the same. I've added a 500 ohm pot to the 1k pot for fine adjustment, so I'll get it as close as I can get it. We're going to take some measurements. If you just want to check it yourself, grab a pen and a bit of paper and a calculator and do it as we go. And then on my next video I'll explain to you what's happening within the magnetic fields and why everything works the way it does. So okay, the first thing we're going to do is, of course, like I said, I'll keep it as close as I can to 120 milliamps input at our set 24 volts. I explained in my last video why I'm using 24 volts. In my last video you'll also know how I'm measuring the voltage across the coil, which is not the voltage the battery is putting in. Okay, so the first thing we're going to do, standard pulse motor. We'll get our watts going in and our watts going out to the charged batteries, and we're doing this so as to eliminate any theory about the lost charge wattage being used to generate our power on our generator side. So okay, at the moment we're at 120 milliamps at our 24 volts. That is the reading we're going to use throughout the video. Now I will be doing this one-handed and trying to do multiple things at once, so I'll do the best I can at keeping the camera still and everything that I do within view for you all to see. So it's our 24 times 0.120 amps. Okay, 2.88 watts. So I'm going to write that there because that's not going to change. That is our usage from our machine at the moment, and that's how our wattage input is going to remain. So now that all my meters are just timed out, I'll turn them all back on. Okay, so our RPM, now this bit of plastic's just sitting there because my rev counter light was bouncing off of that and giving me all stupid readings. Like I said, I am going to be doing this one-handed, swapping hands with the camera, so I'll try and keep it as still as I can. Didn't reset it. Okay, so at the moment it's doing 1168 RPM, as you can see. So we'll write that on our notes. So 1168, and as we know the generator's not hooked up, so there's 0 volts in that. Now we'll do our charge watts. This cores 32 milliamps, 25.7 volts. So once again we'll do that. 0.032 milliamps, 25.7 volts. So that is 0.822. And I'll just check that again. 0.032 times 25.7. 0.822. Okay. This is close enough for us. Okay. Right, so that's the coil voltage at the moment across our run coil is, as you can see, just over 6 volts. The digital meter says 6.12, so that's what it is. 6.12 volts across our run coil. Okay. Also across our trigger coil is 0.598, which I will write down as well, because we will need to know that. 0.598 volts AC. That lets us know how many volts are going into our base from half of the wave of the AC voltage, which in turn determines how hard the transistor switches on, of course. Alright, so now we've done that, what I'm going to do, like I said, I'll be keeping our milliamp draw as close as I can to our 120. So as the rotor starts to speed up when I hook the generator up, I will wind the pot down to keep our watt usage the same, so I will do that now. Get our nice bright light coming on. As you can see, it climbs because the rotor's moving harder. Like I said, I will try and keep it as close to the 120 as I can. It will take a while to speed up and settle down. There's not much I can do. I can't make it go any faster than it wants to go if we want to do the test properly. So I think she's pretty happy there. Okay, so the first thing we'll do is our charge voltage. Like I said, I wasn't really interested in that, but this is just to prove that that light is not running off the loss we just gained in our charge voltage. So flicking between 25.6 25.7, so we're sticking with the 25.7. Keep the test exactly the same. I'll wind it down as close as I can get it to our 120. Okay. don't think we'll get much closer than that. So now we have 18 milliamps at our 25.7. Which we'll do now. Oops, 0.018 times 25.7 gives us 0.462 watts. So charge watts with our generator hooked up, 0.426, and we had 0.822 before. So our 0.822 minus our 0.426, our loss on our charge was 0.396 milliwatt. Okay, so what did we gain? We have 61 milliamps at 11.2 volts. So it's our 11.2 volts times 0.061 gives us 0.683 watts from our generator. As you can see, it's more than we lost in our charge, while still remaining the same watt input to the motor. The other thing interesting here, I will do a RPM measurement while we're here. You can see now we're doing 1397 RPM. 1397. I'm just doing those calculations as we speak. So our gain in that was 229 RPM by adding a load to the motor. Right, coil voltages. Our AC voltage to our base on our trigger coil has dropped, and the voltage across our run coil has also dropped to 4.41. So our run coil voltage is now 4.41 volts, and it was 6.12 without the load. So we've dropped the voltage in the run coil, but we haven't adjusted the watt power going into the machine at all, simply by hooking up that load. That's what's happened within the run coil and the trigger coil. So I know you're going to be asking questions, how can you drop the voltage across the coils without adjusting the watt power going into the machine? Well, that'll come in the next video, and that's due to the magnetic fields within the generator itself. So our next test is, as you'll see, 120. We're putting 18 milliamps at our 20. Well, I've dropped to 26 because we've dropped our milliamps on, but we're going to stick to our 25.7 because that's what we were going on before. So what I'm going to do now is I'm going to put a dead short across the coil, across the generator coils. See, we've got one side and our other side is here. So I'm going to put that on there. The motor takes off. Of course our watt usage goes right up, but I'm going to back that off to our 120 once again. Okay. Very hard to get it spot on, but there we are, pretty close. Right, first thing we'll do here is now check out our charge. We have 47 milliamps at our 25.7 volts. So 0.047 times 25.7. So we've got 1.2 watts of power coming out of that now. Our charge watts 1.2 watts. Pretty sure I done that right. What was it? 0.047 times 25.7, which was our voltage. It's our batteries and our voltage. So 1.20 watts. So that's what we've gained now in our charge, whilst keeping the watt draw to the generator still exactly the same as it was before. 24 volts at 120 milliamps. Now the other thing, the voltage to our base has now gone up to 0.6 volts. The voltage across our coil is now just under around 7.25. Yes, 7.25. 7.25. So, okay. Our first test was standard. Our second test, we reduced the voltage across the coil, run coil, by adding a load to the generator coils. We gained 0.229 or 229 RPM from the motor running itself, and we also gained we lost on our charge watts, but we gained wattage in our generator coils more than we lost in our charge coils, our charge battery, return voltage to the charge battery. And when we've shorted it, we increased our RPM, which I haven't done yet, so we'll do that now. Our RPM is now 1622. 1622. So that's the test so far, to show you what's happening within the coils, generator, charging system, whole shebang. Every test done under the same wattage going in, which was our 2.88. And the different effects that it has with different loads on the generator coils. So as you can see, the more we load the generator side of it up, the more torque we get on our shaft, the higher the RPM, we can lift the voltage to the base of the transistor, and we can lift the voltage inside the coils without altering our wattage going into the motor. So that's it for this part of the demo. Tomorrow night probably I will go through what's happening within the magnetic fields and why this thing is speeding up while producing extra current. without putting any more into the machine. There was talk about the sweet spot. We'll do that test tomorrow, which will eliminate that as well. Okay, well, we'll go and upload this. It'll take a few hours on YouTube, a bit slow, but I'll get it done as soon as I can for you to have a look at. Cheers from the Tin Man.